Good morning. Hi, my name is Jeremy Barton.
And my name is Levi Broderick. And thank you all for joining us here in Seattle and around the world, wherever you happen to be, comfortably in your pajamas, I hope. So we're on the .NET team. We work on the libraries portion of the .NET team. What does that actually mean?
In our normal day jobs, we're both responsible, along with several other people, with most of the things that start with system dot in .NET. And we happen to also both be on the API review board. So you may have seen our smiling faces 10 a.m. Tuesdays and often Thursdays Redmond time on the API review live stream, where we discuss the things that go into the .NET BCL. But we're not really here to talk about any of those things today. We're here to talk about cool things you can do with things we've already done.
Yeah, so let's go ahead and I will get us started. So today we're going to be showing off a bunch of cool things that were added over the past release or two to .NET, including the runtime, the language. And these are things that made us more productive, that made us have better performance in our projects. And we're hoping to share these with you too, so that you'll hopefully find value in them as well. So what I have here is a sample application, which I'll just walk through it. This application is going to we create a regex that's looking for 4 kinds of animals, either singular or plural. You see that optional S at the end. It's going to take as input a target directory. It's going to enumerate all of the text files in that target directory. It's going to match each line and say, does this regex exist within this line, yes or no? And if so, it's just going to print to the console, here's the name of the file, and here's the line that matched. So I'm going to go ahead and build this application. The build command is, in .NET we call it publish. This is going to create an executable that can be run, and I want the release configuration for full optimization. So compile that. It'll take a few seconds in the background. If I go ahead and list the output directory, there we go. There's my executable. So let me show you what text files we have. My corpus is the Odyssey, Pride and Prejudice, and War and Peace. Let's just go ahead and run the application. And there we go. You can see that Tolstoy really likes talking about animals. Really likes it. Jane Austen, not quite so much, only 2 matches. And Homer has a few matches as well. Now, go ahead and looking at these files again. This deployment model follows the same deployment model that has been traditional in .NET. This executable requires the framework, the .NET runtime, to be installed somewhere on the machine or otherwise accessible from your environment. If you remember the days of .NET Framework, like one of the prerequisites before you could deploy your applications was to tell your target customer, go to the Microsoft website and download the installer for the .NET Framework, and then the customer would run the installer, and then you could actually, run your application on the customer machine. What we allow in newer versions of .NET is what's called a self-contained deployment. So you can go ahead and you can say, I want to publish my application, but I want it to be self-contained. What this will do is it will actually take the runtime and deploy it side by side along with your application. So you can then take all of the files in the resulting folder, zip it up, send it to your customer, and say, there's no prerequisite installation. This is all that you need to run the application. When you do this, you also need to specify a target architecture, because we're deploying the runtime along with your application. So you need to say, well, I need the runtime specific for, in this case, 64-bit Windows. Go ahead and hit enter, and take a look at the output of the directory, and oh my, that is a lot of files. And this kind of makes sense from the perspective of well, we took the entire runtime and we deployed it along with your application. And the .NET runtime, as we all like to say, is powerful, but it's big. This includes networking. It includes JSON and XML serialization. And my application, my sample app, wasn't using any of that. So what do we do here? Well, let's make life a little bit easier and say, you know what? Instead of a directory with 150 some odd files, let's see if we can at least collapse it down to a single executable. That's the first step. So I'm not making any changes to my code. I'm only touching the CS file right now, or the project file right now. So what I say here is I want to publish a single file executable. Go ahead and rerun the publish command, and then take a look at the output directory again. And the output directory now contains a 66.8 megabyte file. Well, again, that's the entire runtime. The entire runtime in the app is 66.8 megabytes. Kind of large. Okay, well, I don't want to deploy a 66.8 megabyte file, right? Like, my customers don't want something that large. In newer versions of .NET, we also allow what's called application trimming. Application trimming is basically a way for the compiler to take a look at the code that you have in your application, everything that it calls, everything that that calls, and so on. And what you're left with is a set of all of the APIs that are statically reachable from your application, and a set of all of the APIs that are not used in any form by your application. And once we have those two buckets, we can just kick the bucket. That's not a good example. We can just get rid of the second bucket. We don't kick buckets. That has a different meaning. So let's go ahead and show how that works. So in order to enable trimming, I'm already publishing a single file, and now I want to say, you know what, publish trimmed. Again, add that to my CS proj, go ahead and save it, redeploy my application. There will be a few seconds delay while it figures out what that graph is, and then we went from 66.8 megabytes down to 11.9 megabytes. That is an 80-something% savings in disk footprint. If you have a web deployment, this is great because you spend less time uploading it, the web server spends less time having to process all of this, and it's fantastic. And again, just to demonstrate that everything still works, go ahead and run the application, and there you go. We got rid of networking, we got rid of serialization, it's all gone. So, this is a performance talk, right? So we talked about reducing your footprint on disk, but can we actually improve the runtime performance of the application? Well, as with any good performance talk, every good performance story starts with stopwatch. So let's insert one stopwatch into the application there. At the very beginning, we create a stopwatch, and then at the end of the application, we write the total elapsed time to the console. And we want to measure each individual call to regex. So we start before regex matched, and we stop after regex matched. So this calling start and stop like this in the loop will simply start and then pause the timer around each call. So the final value that we write here will be the cumulative time across all those different regex calls. So go ahead and republish the application, wait a few seconds, and rerun it. And you can see that this took 150, 160 milliseconds to run. So that's the baseline for our application. Keep in mind that I haven't actually changed any of the application logic. The only thing I've done is insert a stopwatch because I wanted to show this. But all of the changes I've made to support publishing only touch the project file. So what if we actually were willing to make some targeted changes to the application? We have in .NET 7 this cool concept called source generators. So let me demonstrate that by way of an example. In a source generator, what you do is, so take this regex. Instead of compiling this regex on the fly, which is what the .NET framework would do, I want to pre-compile it inside of my application. The way that I would do that is, there we go. I would create a partial function that returns a regex, and let's just call that partial function animals regex, for lack of a better term. You'll see that this is a compiler error right now because I have a partial function, so I need to go up and I need to make this a partial class as well. And, okay. Now, this method has no implementation because it's a partial method. A source generator provides the implementation of this method. In this particular case, I'm going to use the magic attribute generated regex, which invokes the source generator for the regular expression engine. The parameter that I pass to generated regex is the exact same thing that would be here in the regex constructor. So I just copy and paste that. I don't need this line anymore, so delete it, and animals regex. Great. So what this is doing is instead of using the regex that I defined at the top of the file, it's going to call this helper method in order to compute the regular expression over all the text in the file. Well, what's actually happening here? If you hit F12 on this, this will actually dive into the code behind that the source generator is creating. The comment at the very top of this file describes exactly what regular expression is being matched, so you can look at this and kind of get a very high confidence level that the regex pattern that you typed matches the regex pattern that you actually wanted to run inside the code. If you scroll down a bit, and I'm not going to show all of this code, but if you scroll down a bit, you can see that there's some really clever bit manipulation and bit pattern matching going on here. This code here is the actual tailored regex specific to your application. This is the engine right here. You're no longer using the engine that's part of the .NET framework. So if I go ahead and save and republish this and rerun the code, you'll see that, remember, we went from 150 to 150 milliseconds, and we go down to 50 milliseconds. Like, this is, a 200% speed up in terms of performance. And the reason for that speed up is we're not using the older, more general regex engine that's part of the framework anymore. We're using one that's custom tailored for your application. If I go take a look at the size of the file, 11.6 megabytes, down from 11.9, because we realized you're not using the regex engine anymore. You're using something that's compiled as part of your application. So take the generic regex engine and throw it away. Your app's not using it anymore. We have source generators for JSON serialization, for platform invocation, and other components. And I hope this shows you that the combination of source generation and publishing is a really powerful way in order to get you both better performance and a lower footprint for your application. Jeremy, let's hand it off to you.
Cool. So on a completely different topic, I have here a program that just does a very simple calculation. It does the standard deviation and mean, because you need that for the standard deviation, of a list of integers. And yay, it prints something. So as we've all seen in programs that we write, we have a thing that's working great, and then somebody comes along and gives us a silly extra requirement that means that we have to write more code. So in this case, it's that now, in addition to the signed int 32s that we support, we have to also support ulong, or unsigned 64-bit integers. And as everyone knows, whether or not it's true, there's no single type that can represent values both from int and ulong. So we're going to have to do some more work. And everyone knows exactly what that work involves. It's start here, hold down shift, copy all of our code, and hit paste as soon as I can figure out where paste is. And now we just start changing all these little ints to ulongs, right? Okay, I could actually go through this exercise, but it's not very interesting. It turns out what we want to do is just a thing that everyone, when they first start working with .NET and C generics, wants to do. They want to just say, work with some arbitrary type. So let's just go ahead and write this as if it was a generic function, and that would just work. So we'll do the mean. It works over a t. And we see that this, we know we need to change this int to a t as well. And now we have a problem that, for some reason, we can't add to a double some arbitrary t. But it turns out now really with .NET 7, this has been a multi-year project, we can. So all that we need to do is say that t is a number. And it'll say that we still actually can't, because we don't know how to convert an arbitrary number into a double, but it turns out double actually knows how to convert an arbitrary number into a double with this new function, double.createChecked. It also has, we have create saturating, create truncating, and create checked. Checked just means if the value can't be represented as a double, then it will get an exception. Why are we unhappy? Because I pasted that in the wrong place. Live demos.
Excellent.
So now this mean should, so now our standard deviation says we can't call mean because it has more constraints than we do. So we say where t is an I number. Now we can call mean. Our for each is unhappy because we need to substitute some letters. Our subtraction is unhappy because we were still relying on that implicit conversion. And now we have a program that theoretically compiles. And we run it, except it doesn't compile.
Braces.
Do I have too many now?
Yeah, just like how teenagers hate braces, Visual Studio hates them too when you get them wrong.
Yay, so now we have done the standard deviation of both an int and ulong. And in fact, we can go ahead and take the old code that we had. We didn't actually need to copy paste it. We could just make it generic, run that again. We still get an answer. And yay. Well, it turns out we can also use this for non-integer types, because I didn't say it's an integer, I said it's a number. So with that same code, we can now compute the standard deviation and mean of a list of floats. And we have a new type, int128, which actually could have held both of the previous numbers, but hey, look, we can compute the standard deviation over that. And all of these are fixed width types, which are things that we just think of when we think of with numbers. But it turns out in .NET we also have big integer, which is an integer of arbitrary size, and it turns out it's also an I number of t. So now with this one set of code that you only have to write once and debug once and whatever else you feel like doing, it works with all of the numeric types. So this is the generic math feature that is, I think we just completed it in 7.
Yeah, it ships as part of .NET 7, you're right, yes.
Yeah, so it's been a multiple release effort involving some previews, and this time it's finally ready and done. So when .NET 7, which hit RC2 on Tuesday, and it'll be fully released in a month-ish, I think, assuming I know the schedule. Yeah, so that's generic math.
Yeah. Woo, thank you for the demo, Jeremy. Let's go ahead and flip back then, because I think I'm ready with my next one. So here we go. This application attempts to solve a scenario that I'm sure we've all had multiple times. I have 2 files on disk, and I want to know if their contents are identical. I'm sure we've all either written these utilities multiple times or scoured the internet looking for somebody who has already written these utilities so that we can use them. Let's just go ahead and look through the code first. This main method, the skeleton, is just a very simple read the file names from the command line and pass them into a helper function. Again, our trusty stopwatch, because we love stopwatches here. The actual helper function, check both file names to make sure that someone actually gave us values and not just empty strings. Open the 2 files for read. Make sure that the files are the same length, because if they're not the same length, they can't possibly have identical contents. So now we need to read the files in a loop. So we create a buffer to read the file contents into. Inside the loop, we compute how much data to read during each loop iteration. It's 16 kilobytes or however much data happens to remain. We read from file 1, we read from file 2, then we iterate over the buffers, making sure that all of the bytes are equal. If any byte is unequal, fail. And if everything passes, then we return true. Excellent. Pretty straightforward code. I don't think I have any comments on it right now. Let's just go ahead and take a look at, first off, let's take a look at the 3 source files that we want. We have foo, bar, and baz text files. You can see here that foo and bar are not equal. Foo and baz are equal. So let's just go ahead and run this code real fast.
Jello World sounds like a
Jello World,
park.
Yes.
Everything.
Would you like to go to Jello World?
As long as it's the pudding and not just the gelatin.
So if I compare foo and bar, this is going to print that they're not equal, as we expect. Everything's going to work. Let's compare foo and baz. Clearly, it's going to say, everything's equal, and life was good until I ran this demo. Jeremy, help, please?
Well, I mean, the first thing, conveniently because your cursor happens to be sitting next to it, is that stream.read returns the number of bytes it read, and it's not actually guaranteed to return the count, right?
Oh, so this could actually return fewer bytes than I'm expecting. Yeah,
it turns out this is actually with a type that I have the pleasure of owning called CryptoStream. We actually changed the way that read worked in it 2 releases ago, and this has thrown off a lot of people because they kept assuming that read would actually just do what they asked. But read instead does what it's documented to do, which is reads up to count number of bytes.
Yeah, so I'm going through and I'm changing this. So I'm having it read as much data as it possibly can into the buffer. So the first read is going to read some number of bytes, and I'm storing it into this variable here. And now I need the second read from file 2 to read that exact same number of bytes. So I guess I'm going to have to write a helper method, read exactly. And yep, that helper method, I'm sure all of us have written before multiple times. So now, So I'm calling my helper method. Let me update the loop here so that it compiles correctly. And now I think we're good. Yes, let's go ahead and try this code. First over foo and bar, which should say not equal. And then over foo and baz, which should say equal. OK, great. The code is fixed now. And that took 10 milliseconds to run. Excellent. Well, since you're here, any other feedback?
Well, since .NET 7 is practically out the door at this point, it's convenient that you named your helper function read exactly, because it turns out in .NET 7 we've added on stream a function called read exactly, which will do exactly what you want it to.
You're right. So I can, you're right. It's literally called read exactly. I can get rid of my helper function here. Come on. OK, so, OK, neat. Any other feedback for me?
Well, so you have this loop and compare these bytes for equality. And while that functionally works, it does take 4 lines of code and is actually reading byte by byte. If you just use spans in all of this, then you could use span sequence equal, and that's actually vectorized, so it'll be about 8 to 32 times faster, depending on how wide your registers are.
Yeah, let me go ahead and actually give some context to what Jeremy just said. So by way of running this over large data files that I have here in my directory. So these 2 files, they have the same length, but different timestamps, so I'm not actually sure if they're equal or not. So let me go ahead and run my application, because if I want to know if they're equal, well, I just made an application that tells me that, so I may as well, get my mileage out of it. So it's going to say, OK, it's comparing file 1 and file 2, and it took 650 milliseconds to run, and it said that they're equal. OK, so if I were to go ahead and spanify this, what would that actually look like? Well, the first thing that I want to do is I want to wrap my arrays into a span. So that's going to look like that. The way to think of a span is a span does not necessarily contain data. A span instead wraps some other structure that contains data. In this particular case, a span wraps an array. When I read from or write to a span, I'm actually, under the covers, reading from or writing to the backing array. And spans can also be resized, because spans are windows into these buffers. If I go ahead and change this so that I'm no longer reading into the array, I'm reading into the span. If I go ahead and say, OK, I have read this number of bytes into the span, so now I want to shrink the span so that the span is properly sized to the amount of data that I actually read. So we have this awesome method called slice. Remember how I said that a span is a window into another buffer of data somewhere? The slice method resizes the window without actually resizing the backing buffer. So when I'm calling slice, I'm not changing the backing array, I'm not resizing it, I'm simply saying the size of my window has changed. OK, so I've sized span 1 to be the exact number of bytes that we've read. I've sized span 2 to be the exact number of bytes that we want to read, and now I'm going to read into span 2. And read exactly will, again, fill span 2 exactly with the number of bytes that is specified. So instead of this for loop here, let's just make this a call to sequence equal, like Jeremy said. We have a bunch of helper methods on span. One of them is sequence equal, and sequence equal says, if these 2 spans have different contents, return false. If they have the same contents, return true. And because we're not iterating byte by byte, this method under the covers can use new compiler features and new processor features like SIMD, symmetric multiprocessing, so that it can perform multiple computations at once. If I go ahead and then run this over the application again, you can see that the application performance has increased somewhere between 3- and 4-fold. This is not a proper benchmark, because I'm just running this with a stopwatch instead of a proper framework like benchmark.net. But even outside of a proper benchmark scaffold, you can see that this is a significant performance increase for this application. And all I had to do was just change my usage of arrays to use spans instead. Any other feedback, Jeremy?
I mean, the loop, well, I guess I see 2 things right now.
Yeah.
Depending on what you want to do. The most interesting one is you have this public function.
Yeah.
And since you work on the API review team, you should know about proper exception handling. You're not actually doing proper, or what we would consider proper exception handling, because you're throwing argument exception instead of argument null exception when it's null. But instead of fixing that here, why don't you just call the helpers we added?
Oh, so those helpers are, they're on argument exception, right?
I think so.
Yes.
Yeah, that's where we put it.
Yeah, file name 1.
We debated that one for a long time.
Yeah, okay. So we have helpers. In this particular case, this helper is going to throw if the incoming argument is null or empty. So the empty string is forbidden. There's also a helper that's just throw if null, if you prefer that instead. Empty string file names really have no concept here, so I'm checking null or empty. But if we compare these two lines side by side, this first line is significantly shorter and significantly more readable than the second line. You can see the second line doesn't even fit on the screen for this review here, which is kind of convenient because if I'm just passing file name 1 here once, then I know that I don't have to risk, passing the wrong thing here. So this is equivalent, passing name of file name 1. That is equivalent to leaving off the last parameter entirely, so that you don't necessarily make the mistake of accidentally passing the wrong file name. And in fact, you can see that I actually did have a code which was masked, or did have a bug, which was masked by the fact that my code didn't even fit on a single line, because I am checking file name 2 here, but I'm throwing an exception with the name of file name 1. So if I just change the code to do that, great. Like, I don't need to risk getting those mismatched anymore. There are other opportunities for improvement here. One of the things that we added in .NET is called the array pool, so that we don't necessarily have to create new arrays every single time you call a function. In this particular case, we're renting an array from the pool, slicing it using span, and then performing our logic, and then returning the array back to the pool when our logic's finished. The benefit of this is if you're comparing the contents of two directories, you might be calling this over and over and over in a loop. And if you're doing that, well, you don't necessarily want every single file to allocate 32 kilobytes of throwaway buffers. I think that's all I had for this. Thank you so much for the review, Jeremy.
Yeah, the array pool was the last thing I was going to tell you, but
yeah,
you beat me to it.
I did. I didn't want to take up too much time.
Let's go a little bigger. Okay, so files. They all start with a series of bytes, and oftentimes that series of bytes tells us what a file is. And Wikipedia, which is running a campaign this month, and you all use it all the time, and you should totally give them money, has a web page of a list of file signatures. So what I've done is I've built a program that I went through this list manually, so I'm not guaranteeing it's accurate, and found everything that looked like it was an image file format. And I copied all of the bytes into a structure in this program that's a little wider than you can see. Maybe I can close things. Maybe I can be smart enough to close things. There we go. And so, we can find from the table there that Windows ICO files start with 0010 and so on. And so I have a couple sample files, and we can go ahead and prove that the program works. And oh, look, it opens a bunch of files and it prints a bunch of strings, and you can probably trust me that it does what it's supposed to do. But in a stylistic perspective, we can see that up here we have what the actual bytes are, which we then gave a name, because that's a convenient coding practice. But then what we have down here, if we're trying to debug it, is we see only the semantic name and not the actual value with our return.
So this is kind of interesting. So you have a bunch of static properties, and these properties are returning spans that we just talked about. They're views over byte arrays. But inside the property getter, you're calling new byte array every single time. Like, doesn't this just allocate tons and tons of memory every time you call it?
You would think so.
I would think so. That's why I said it.
And but it turns out that there's an optimization in the Roslyn compiler that we depend on heavily in the BCL, which is if you have a property that is returning a read-only span of a single byte data type, which would be byte, sbyte, and Boolean, and you have it written as a get to a new literal array, then it just kind of does some magic and maps that once into static data and then returns us the same span every time. I wish it had a name, and I wish it had a better syntax, and it turns out both of those are being debated right now. But in the in-market versions, we've had this since .NET 5 or 6. This pattern works and is a nice way of dealing with constant literals. So using a new feature from C# 11, we can actually go ahead and squish the data value and the return value into the same space. So let's go ahead and just copy the pattern here for ICO. And first, let's just wrap our function here with a local, so we can save what we used to do. Read only span.
So one cool thing that Jeremy's using here is a local function. So he's defining a function within a function, and it basically just scopes the context in which that function is callable, so as not to pollute like the entire surface area of your type.
Okay, so in C#, some already shipped version, we've gained support for what's called expression switch, which is the same as the statement switch, except it's an expression. The syntax ends up flipping, but the expression switch gains support for various patterns in matching, which we have been added in various forms over the last few releases. And we're going to take advantage of a new one here, which is called the list pattern. So we can go ahead and take, instead of using curly braces like we did for the array, we use square braces to say if we see this sequence of 4 bytes, we'll go ahead and return ICO. And then because I made it in a return, I need to say what happens if we see something we don't see, which is we use the discard operator, and then that'll just call the old way. And since I've already moved ICO up, we can go ahead and delete this, and we run it. And unfortunately,
unknown.
We no longer detect ICO, but there's a very good reason for that.
So can I make a suggestion? So is this matching only the 4 bytes 0010? Like, is it saying that the input actually has to be exactly 4 bytes?
It is. So
okay.
Since I have a left brace and a right brace, that's saying that this is where the start is and this is where the end is. And previously I was checking starts with. So it turns out there's a syntax. It's rather like you would do if you were writing some English, where you would write ... but it turns out in C# it's only ... because that aligns with the syntax that we used in range. And now with ... we're back to seeing that this is an ICO.
Cool.
So now we can go ahead and start bringing some more of our data up, except now we get a red squiggle down about here.
So what's the error message on that red squiggle? Can you read it
Very
aloud?
small,
yeah.
But it says the pattern is unreachable. It has already been handled by a previous arm of the switch expression or is impossible to match.
Oh, so it sounds like this is one of those cases where like you wrote if A then do something, if B then do something else, but A was already kind of a superset of what B was, so B's actually never going to get matched. Is that kind of what that's telling us?
Yeah, so it looks like here, I'll just move this up for clarity, which also happens to remove the syntax error, that the first 4 bytes of TIFF Little Indian and the first 4 bytes of Canon Raw 2 are the same. It turns out that's not a coincidence. Canon Raw 2 was actually a special cased version of TIFF Little Indian. And so the program, which was the order that everything was written in the table on Wikipedia, I never tested with CR2, and so there was just dead code there.
So this was actually a legitimate bug in your first program that using the new syntax uncovered?
It was, and apparently I did test it with CR2. I just had a test case that was named wrong.
That's kind of cool.
All right, so we can continue bringing up extra forms of things until we get to an interesting thing here, where we said...
So you have 2 things that return the same value. So how do you represent that in a list statement then?
Yeah, it turns out the JPEG group, they really, really, really like having multiple header values. So we see here JPEG 2000 has 2 rows in this table. And well, we have the logical statement or that we all know to just read the double pipe operator as the word or. In the new syntax with pattern matching, we write the English word or, and can pick any style you want if this is indented or not. You know, we're a non-style language. So I went with aligned because it means all the bytes are aligned. And we can continue on here, and we still detect JPEG 2000. Of course, you can't prove that because I fall back to the old function, so we'll do more code. I still detect JPEG 2000.
Cool. So you also have, so you have another interesting pattern in this old function. Your checking starts with, and then you're checking the length separately along with like a mid-array slice. What's going on there?
Yeah, so slightly further down, we see this wonderful entry in the table on Wikipedia, which has 8 question marks in it. And what this means is these bytes are irrelevant. It turns out the format that they're using here, it's a tag length content syntax, and in this case, it's the first tag is FORM, then it has the 4-byte length value, and then the next tag is ILBM, which identifies this file format. So what I had to do in the code when I copied this table is look for those first 4 bytes, ask if there was enough room to go ahead and check the third 4 bytes, then do a slice, and then do another check. With the list pattern, with the list pattern, we can use the discard operator that previously we're already familiar with, and we can just say these 4 individual bytes are allowed to have any value. So now it'll check the first 4, the next 4 don't matter, and then it'll check the 4 after that. Instead of running it, because it's going to be in a weird place, I'll go ahead and just explode the rest of the table. So with this, I can now just straight up delete everything that was in old way. And run that, and we're back to detecting everything except file 6, which is ASCII art, which doesn't have a given format. So one interesting thing with this, because certainly what you can have here is a debate of whether the syntax of before or after is prettier. This, in the style that I chose to write it, makes for some very long lines, but the data is, the input data that's matched is right next to the return. The C# compiler, when we give it this expression, it actually goes through and it builds a more optimal jump table. So before, every time we hit another if, we had to read the first byte again and ask, are we still making progress on our starts with? And so we read the first byte. In the case of the unknown, we read that as many times as we have entries here. In this, so I'm going to use there's a tool called SharpLab that we use a lot on the runtime and libraries teams for seeing what inputs we produce. Often we use it for C# into what's the final machine code. In this case, we're going to use the C# to C#, which shows that this pattern as input produces some very interesting looking code, which I can't guarantee that this happens. It hopefully does. No individual byte should be read more than once on any pattern. So if I had done a good job of aligning the code where I wasn't actually I/O bound, I could have shown some perf numbers, but I wasn't. So you'll just have to take my word on it.
No, that's awesome. I appreciate you showing the generated code as well. I think that really explains, that the compiler is doing something smart under the covers here. I don't have anything else to demo, do you?
I don't either, so I think we can start taking some questions.
Yeah, I think we have a few minutes left. Thank you so much, again, both here and elsewhere. And questions?
Oh, test, test, test. All right, let's take a look at some questions here. I'm looking at the teleprompter. These questions may have come from outside and our friends at home or from our friends in the room right here. Question here from Atul, is regex attribute available with the .NET framework as well?
So this question is referring to the source generator that I described earlier. I believe that is not available with .NET framework because I believe we had to make changes to how the regex type is implemented under the covers in order to get this to work. And those changes were only made in newer versions of .NET.
This is my question. How important do you think that these things like source generators are? Because there are people who kind of like scratch the surface of using .NET and using C#, and then we give them these features, and some people might go, oh, that's really complicated. But the benefits are really significant, aren't
The
they?
benefits are significant, and some of the other source generators, like I had mentioned that there's one for JSON, I believe that that works across older versions of .NET as well. But don't quote me on that because I haven't tried it, but I don't see why it wouldn't work. Features like what Jeremy showed off, where you have properties returning spans, that's a compiler feature, not a .NET Framework feature. So you can use a fairly recent version of the compiler, even targeting .NET Framework, and you will still get that benefit.
I noticed on that example that you had the regex, and then you got it working, and then you made it fast. You got it working, and you made it smaller. Is that a reasonable way to do things?
I think it is, and that's the TikTok pattern that we've used inside our own libraries when we've been writing them over the past few years.
All right, cool. Question from Vishwas, who's asking, and this is may work or may not. They're asking, can app trimming help with containerization? Like if you're going to move an app into the cloud, is there a connection between that, Jeremy? I think about density. I think about container size.
Yeah, so if you are only going to have one application on your container that's running .NET, then trimming that application down would help, and you wouldn't need to have .NET as a prerequisite. If you're going to have more than one, you start running into interesting cases where it might be more beneficial to have the shared runtime installed and then make applications on top of that that just use the shared runtime. And in fact, since we provide containers with the shared runtime already on them, again, once you're going to have more than one app running in the same container, you probably just want to start with a better base.
Yeah, and there's a movement. I know we did some work with Ubuntu to make the containers even smaller, to ship as few bits as possible, not just because of size, but because like philosophically, if no one ever called that function, then its existence is a threat. Therefore, let's just not ship it. And we are talking about application trimming, but now we're talking about operating system trimming. So I'm not even going to ship that function because it's just not needed. So we'll trim it all the way down into nothing.
And for the question of is generated regex available in .NET Framework, a PM on the libraries team runs the website APIs of .NET, and we can see here that this is only available in .NET 7 and newer.
.NET 7 and newer, okay. Here's an interesting and a little bit challenging question here from David, who's saying, is this more about general .NET performance or cloud performance, more .NET than cloud? And I have an opinion about that. But.
So for what we showed today, this applies to all different project types, even projects that you're going to deploy on premises rather than in the cloud. A lot of the things that we've been talking about, especially with regard to how do you lower memory usage, how do you lower CPU usage, that's really, really important when you talk about the cost of operating your service in a cloud. But really, this does work across all different deployment models, regardless of where you've deployed it or how much money it costs for you to deploy it.
Yeah. And then are there analyzers that will provide suggestions to convert to the new switch expressions? Question from Jeremy.
Hello, Jeremy.
You know which Jeremy this is too, right?
Well, everyone who uses .NET is named Jeremy.
Oh, is it?
Yes.
I mean, every now and then in the API...
Did you leave that question for yourself?
We'll have Jeremy introduce Jeremy, who introduces Jeremy, and then somebody will say, well, Jeremy told me, and then we're all confused.
As one of the three Scots in my chain, I can respect that.
So I don't know if we have any. It does seem like it would be a reasonable thing, but in a lot of cases, like the one that I did here, that would require, I think, a bit more brain power than we have in the analyzers right now. But for some simple things, it probably does, because we've been eager to make analyzers that make your code smaller while still retaining its functionality.
Question here from Sajal, who's talking about shipping binaries portable versus making independent on the runtime. Is there a performance impact? I mean, the bits are there.
The performance impact, from my experience, is primarily going to be how the binaries were compiled. One thing that I did not show here, but's available on the web if you kind of look through the session notes, is using ahead-of-time compilation. That allows you to have both your application and the runtime already pre-compiled for your target architecture, rather than relying on the just-in-time compiler to do everything on the fly. That's something that we've been making significant investments in.
Mm-hmm. And then some comments, some generalized comments in the chat around, perf. Is this just perf? Is this .NET perf? Is this cloud perf? Perf is perf. And one of my favorite quotes was from the friends at Stack Overflow, who ship performance as a feature. And if you're in the cloud and you don't care about perf and you think that you're just going to move a slider bar, remember that that slider bar in the cloud is connected directly to your credit card. So you can get perf, and it's going to go like that, and then your credit card is going to go like that. But you get more density. Everything gets better with perf, wouldn't you agree? Especially when you're in the cloud.
Yeah.
All right, big hand for our friends here, Jeremy and Levi. They'll step out and go off to the right if you want to go and grill them some more out in that corner section there. We're going to take a short break. And our next talk, we're going to have Fatima and Mark talking about how Visual Studio builds Visual Studio with Visual Studio Live. Thanks so much.
Yeah, thank you for your time. Appreciate it.
Tschüss.